This is number 16 from the review problems, and this is a projectile problem. So in this problem, we have a cannon shot horizontally from the edge of a cliff, 100 meters above ground level with an initial speed of 30 meters per second. We need to draw a sketch, determine the time it takes for the projectile to hit the ground, determine how far from the base of the cliff, so that's my x final. We have to find the y component of the velocity, the x component of the velocity, and the angle that the projectile hits the ground. So we'll first write up our givens and finds. So we have y initial is equal to 100 meters, and we have v initial is equal to 30 meters per second. So we're first going to draw a sketch. And we need to know at the end, we're going to find the velocity final here, and we need to know that angle. So we're looking for time. We're looking for x final. We're looking for y velocity final in the y direction, velocity final in the x direction, and theta. Okay, so the first thing we know when we have a projectile problem is that delta t is the thing that links, so my time is the thing that links my y equation and my x equation, and I know my starting y position and I know my ending y position. So I'm going to start with the y equation to find delta t. So I'm going to find y final is equal to y initial plus v naught y delta t minus 1/2 g delta t squared. And so I know that y final is 0. I know since this is shot horizontally, that means there's no v0y or initial y is equal to 0. So this is 0. And so right now I have just these two terms. So I'm going to bring this to the other side. I'm going to add 1/2 gt squared to both sides. And I'm solving for delta t. So I'm going to multiply both sides by 2 and divide both sides by g. So I'm going to have 2yi over g. And I'm going to take the square root. And so when I plug numbers in, I'm going to have 2 times 100 meters over 9.8 meters per second squared, square root. So delta t is equal to 4.52 seconds. And so that's A. This was A. And now B. I'm sorry, this is B. So writing out my givens and finds and making the picture, that's all A. So C is how far from the base of the cliff does the projectile land? So since I have my delta t and how far it lands is this distance, I'm looking for x final. So I'm going to use the other kinematic equation for x. X final equals x initial plus v naught x delta t plus 1/2 a delta t squared. And this is a and the acceleration in the x direction, so I know that's 0. My initial x position is 0. So I'm just left with these two, and I'm looking for x final. So x final is equal to v naught x is my initial velocity in the horizontal direction, so that's 30 meters per second times my delta t, 4.52 seconds. So x final is equal to 135.5 meters. D, we're looking for the y component of the velocity. So if I want to find v final in the y direction, that's equal to v initial in the y direction minus a delta t. So my initial y is 0, so my v final in the y direction is equal to 9.8 meters per second squared times negative, don't forget my negative, times my delta t, which is 4.52 seconds. So v final y is equal to a negative 44.3 meters per second. And E, they want to know the x velocity, the final, the x component of the velocity. So we know that v final x is equal to v initial x because there's no acceleration. So that's just equal to 30 meters per second. And then finally, for F, we're trying to find the angle. So we're going to use tan theta. And our angle here is, we'll draw this in just a second, tan theta is equal to v final y over v final x. And we'll just draw a little picture here. So my final velocity looks like this. And my angle is here. This is my theta. So this is my v final, and this is my v final y. It's in the negative direction, and this is my v final x. So so that's what we're the angle that we're thinking about. So I'm just going to finish up here. So theta is equal to inverse tan of 44.3 meters per second divided by 30 meters per second. And so my theta is equal to 56 degrees, and it's measured here.